Good afternoon. गुड आफ्टरनून ऑल. लास्ट लेक्चरला सगळ्यांनी आधीच लिव्ह केलं, मी शिकवते आणि सगळ्यांनी लिव्ह केलं. इम्पॉर्टंट डेरिवेशन शिकत होतो ना आपण. दॅट इज ऑपरेशनल एम्प्लीफायर ॲज अ डिफरन्शियल एम्प्लीफायर और ऑप एम्प ॲज अ सबट्रॅक्टर. So op amp as a subtractor equation is output voltage is given by V2 minus V1. Okay, here is your V2 means to the non-inverting input V2 and inverting input there is a V1. नाही नाही मिळाले. क्लिअर दिसतंय आता सगळ्यांना? ओके, बोर्डवरचं दिसतंय सगळ्यांना क्लिअर? ओके, कल्पेश केलाय का होमवर्क? बेल वाजली, 1 मिनिट. सो ऑप एम्प ॲज अ सबट्रॅक्टर होमवर्क केलाय का कल्पेश? So till now, how many applications we complete? Op amp as a non-inverting amplifier. After that, op amp as a unity gain follower. After that, okay. आज करून ठेवा होमवर्क कंप्लीट, म्हणजे तुम्ही कॉन्फिडंट राहाल. कालच मी तुम्हाला म्हणून बोर्ड क्वेश्चन पेपर रीड करून दाखवली. एव्हरी टाइम देअर इज वन क्वेश्चन ऑन दॅट ॲडर. ओके, आतापर्यंत आपण कुठले कुठले ऍप्लिकेशन शिकलो? ऑपरेशनल एम्प्लीफायर ॲज अ नॉन इन्व्हर्टिंग, ओके, नॉन इन्व्हर्टिंग op amp. After that, op amp as a unity gain follower. After that, operational third one, op amp as a inverting operational amplifier. After that, op amp as a sign changer. Okay, op amp as a sign changer. These are 4. After that, 5th one is op amp as a adder, and 6th one is op amp as a subtractor. Means these 6 are the linear applications of op amp. Output is proportional to input. That's why all these are termed as a linear applications of operational amplifier. Okay, we complete all these and we try to simplify some numericals on, I think, two only, on adder. एक एक्सरसाइजचा सॉल्व केलं आणि एक एक्झामला आलेलं आपण सॉल्व केलं. नाउ रिमेनिंग न्यूमेरिकल्स वी ट्राय टू सिम्प्लिफाय टुडे अँड देन वी गो टू द non-linear applications of op-amp. That non-linear applications are operational amplifier as an integrator, operational amplifier as a differentiator, operational amplifier as a comparator, and operational amplifier as a Smith trigger. These are the four non-linear applications of op-amp. These 4 points are remaining till now. Up to now means याच्या पुढे किती उरलेले आहेत हे 4 applications फक्त. Now we try to simplify some exercise numericals. Page number 96. See your page number 96. This is quite simple. Don't leave the class now. All of you. We try to simplify. आजचं सोपं आहे. See page number 96. I am going to read that one. Find the input resistance of op-amp with feedback whose output is minus 12 volt. Means RI. They are asked to calculate RI. Find the input resistance means what you write in given data. Ri is equal to what? With feedback whose output is minus 12 volt. V0 is given minus 12 volt. With input is 120 millivolt. Vi is equal to 120 into 10 raised to minus 3 volt. 120 millivolt means 120 into 10 raised to minus 3 volt. The feedback resistance is 10 mega ohm. Feedback resistance RF is given 10 mega ohm. Now the output having negative sign and input is a positive input signal means this operational amplifier is an inverting op-amp. And what is the equation for inverting op-amp? We already derived the equation for inverting op-amp. That is V0 is given by minus RF upon Ri into Vi. What is the output equation or equation for output voltage for inverting op-amp? V0 is equal to minus RF upon Ri and into Vi. RF upon Ri, RF दिलेला आहे, Vi is also given and V0 is also given. Find out Ri. Okay, do you understand? So write down the given data and try to simplify. Minus 12 volt. This one is given data. From this, that it is not specified whether it is inverting op amp or non-inverting op amp, but input voltage is positive and we get negative output. From this, we come to know that this one is a inverting op amp. Whenever there is a sign change, means output is out of phase with input. At that time, this one is a inverting op amp. And what is the equation for the output voltage for inverting op amp? Write down the answer properly. This one is a required formula of inverting op amp. We already derived this equation. Output voltage of inverting operational amplifier is given by minus Rf upon Ri into Vi. Okay. So now we want to calculate Ri. All other things are given. That's why Ri is equal to minus Rf Vi upon V0. V0 on this side. Therefore, Ri is equal to minus. What is the value of this? 10 into 10 raised to plus 6. Mega ohm means 10 raised to plus 6. Here Vi is what? 120 into 10 raised to minus 3 because it is in millivolt. Milli means 10 raised to minus 3. And what about V0 minus 12? So, plus 6 minus 3 it is 10 raised to it is 10 raised to 3. Therefore, input resistance is given by 10 into 120. It is 1200. 1200 into 10 raised to plus 3 upon 12. Minus minus it becomes plus. Therefore, Ri is equal to 12. 10 raised to 5 ohm, or you may say that Ri is equal to 100 into 10 raised to 3 ohm. Therefore, Ri is equal to 100 kilo ohm, or you may say that Ri is equal to 0.1 mega ohm. One and the same. Both are the right answers. Okay. It's so simple, means only here there is a, up to this point there is our concept of electronics, because we must know what is, whether it is inverting op amp or non-inverting op amp. Do you understand how you recognize that it is inverting op amp? Input voltage is positive, then also output voltage is negative. That's why it is an inverting op amp. So what is the equation? Welcome, Prasad. Listen carefully now. So simple numerical and it may for 3 to 4 marks. Okay. So output voltage of inverting op amp is given by minus Rf upon Ri into Vi. Means 4 variables are there. V0, Vi, Rf and Ri. Out of that 3 are given. Output voltage V0 is given. Feedback resistance also given. Input voltage is given. And you are asked to calculate the input resistance. That was rearranged. That's why rearrange the equation and you get the value of Ri. Okay, what is given in your textbook? The value is 100k. 100k is nothing but 0.1 mega ohm. So write down all these things, then we try to simplify the second exercise numerical. And those who complete, they try to simplify second. Okay. So Rudmai, try to simplify the second one. Okay. These two steps are important. All other are the simple calculations. Now see the second example. 10 millivolt low frequency signal. Do not frighten by hearing that word low frequency signal. Though the frequency is low, what is the magnitude of that signal? It is 10 millivolts. So VI is equal to 10 millivolt, which is equal to 10 into 10 raised to minus 3 volt. Okay. What is the next line? Is to be amplified to 1 volt. What is the amplification of this? Which is equal to 1 volt. Amplified means when VI of 10 millivolt is applied at the input of that operational amplifier, output is 1 volt. Output is 1 volt. What is the next line? Using non-inverting op-amp. Here it is specified that non-inverting operational amplifier is used in a mode of non-inverting amplifier. Non-inverting means this VI is applied to the plus input, that is the non-inverting input, and you know the output equation for or output voltage equation for non-inverting operational amplifier is V0 is equal to 1 plus RF upon RI in bracket 1 plus RF upon RI into VI, and there is no minus sign, there is no phase inversion. Okay, so with this is our required formula, but to calculate that there is a necessity of RI and RF. So what they asked to calculate and what is given, the feedback resistor of 10 kilo ohm is connected. RF is also given 100 kilo ohm. Feedback resistance of 100 kilo ohm is given, and what they asked to calculate now, find the value of input resistance. They asked to calculate the input resistance. So simple. Now here another important data, the given data is non-inverting this one is an important word. Non-inverting operational amplifier is specified. So the output voltage for non-inverting op-amp is given by 1 plus RF upon RI into VI, and plus sign is there. So now we want to calculate RI. So how you calculate? V0 upon VI is equal to 1 plus RF upon RI. So implies that V0 upon VI minus 1 is equal to RF upon RI. Okay, so RI is equal to RF What is the value of RF? 100K. 100 here you have to write, because given data must be in SI unit, so here you have to write 10 raised to 3 ohm. 100 into 10 raised to 3 multiply what is our VI? 10 into 10 raised to minus 3. And V0 is what? 1. Minus VI is what? 10 into 10 raised to minus 3. So how you simplify here? Ri is equal to this 10 raised to plus 3 minus 3 cancel. Here 10 raised to 1000 means 10 raised to plus 3. Here 1 minus 10 into 10 raised to minus 3. 1, 2, 3 means 0.01. 0, 1, 2, 3. So 1.000 minus 0.010. What is the value? 9 minus 1, 8. Sorry, 10 minus 1, 9. Here 9 minus 0, 9, and 0.99. Okay, 0.990. Therefore, what is the value of Ri? Ri is in kilo ohm, 10 raised to 3, and 1 upon means 990. Therefore, 100 upon 99, near about 0.9 something. Sorry, 1 point. What is the given answer? Am I right? Anyone get the answer? Yes, right answer. 1.01 kilo ohm. माझ्या आधी कोणाचं सॉल्व झालंय? एनीवन? प्रसाद, मृण्मयी, कल्पेश, वेदांत. दिसत नाहीये हे आन्सर? झाला. ओके ओके. Okay. Means if you know the formula, then you easily simplify the numerical. These are the mathematical calculations only. So simple. जे तुम्ही जेई मध्ये करता त्याच्यापेक्षा हे कॅल्क्युलेशन कितीतरी सिंपल आहेत. म्हणजे आपल्याला कन्सेप्ट कुठपर्यंत वापरायची आहे. यू हॅव टू रीड द प्रॉब्लेम न्यूमेरिकल केअरफुली. Try to write down given data in proper SI unit and what they ask to calculate. You must understand all these things. Then insert the related formula and by putting the values you get the answer. Okay? After that, third already I think we simplify an inverting op-amp adder. Fourth, in non-inverting op-amp, Ri is infinity, Rf is 0. What would be the output voltage for sixth one? We try to simplify sixth. Okay? खूप मार खाशील. Sixth, in a non-inverting amplifier, if Ri is equal to non-inverting, what is given? This is also important. Non-inverting op-amp. Ri is equal to infinity. Input resistance is infinity and feedback resistance is 0. Feedback resistance is 0. What would be the output voltage for input of 5 volt? V0 is equal to what? If Vi is equal to 5 volt, then what do you write? Non-inverting op-amp, what is the output equation for non-inverting op-amp? 1 plus Rf upon Ri into Vi. Now insert the given values. What is the output voltage? V0 is equal to 1 plus Rf is what? 0. 0 upon infinity into 5. 0 upon something is always 0 or something upon infinity is always 0. So 1 plus 0 into 5. So output voltage V0 this time. V0 equal to or output voltage V0 equal to 5 volt. Means if in that non-inverting op-amp input voltage is input resistance is infinity and feedback resistance is 0. Okay, at that time what is the output voltage? As it is, there is no amplification. Vi is equal to V0. Therefore V0 is equal to 5. Okay, after that find the slew rate. Seventh, we know what is slew rate. Rate of change of output voltage is known as a slew rate, or change in output voltage with input voltage or with respect to time. Change in output voltage with respect to time is known as a slew rate. dV by dt. What is the formula for slew rate? dV by dt. ddt of input voltage. Rate of, sorry, output voltage. So here, what is the seventh numerical? An op-amp take 0.2 microseconds to change the output from 0 to 10 volts. Okay, 0 to 10 volts means what is the change? 10 volts. And upon ka येणार 0.2 microseconds means 0.2 into 10 raised to minus 6. Find the slew rate. So write down 7th. What is the formula for slew rate? dV upon dt. Therefore, dV is 10 volt, dt is 0.2 microseconds. Because the unit of slew rate, practical unit of slew rate is volt per microsecond. So maintain that time in microsecond. Otherwise, you have to convert in 10 raised to minus 6 seconds. But here 10 upon 0.2 means it is 50 volt per microsecond. What is slew rate? It is 50 volt per microsecond. Do you understand? Slew rate is one of the important parameter of operational amplifier, and slew rate, the definition of slew rate is rate of change of output voltage, or you may define slew rate as change in output voltage with respect to time. So what is the change in output voltage? It is given 0 to 10 volt. If it is given 2 to 10 volt, at that time what is the dV? 8. 2 volt to 10 volt असं आलं असतं तर आपल्याला dV ची व्हॅल्यू काय आली असती? 8. इफ द चेंज इन आउटपुट व्होल्टेज 5 to 10 volt असं असतं तर dV ची व्हॅल्यू काय आली असती? 5. But here it changes from 0 to 10 volt. So what is the deviation in output voltage? 10 volt. And what is the required time? Required small part of time during which that changes. Yes, yes. Internet connection break झालेलं, Wi-Fi झालेलं. After so many days. माहिती नाही, मधनं ते कनेक्शन ब्रेक होतं. या टायमिंगला होतं फक्त जनरली. 11 वाजेच्या लेक्चरला कधी नाही व्हायचं. Okay, it's okay. Now I am live now again. So we will continue. Next numerical is on integrator. Before going to that, now we try to simplify, or after that some exercise, solved numericals are also there. Now you go through it. Solved numerical book मध्ये दिलेले आहे, तुम्ही ते सहज समजून घेऊ शकता. ते आपल्याला इथे डिस्कस करायची गरज नाही. Similar numericals are given, means solved in your textbook. Go through it once. Okay. So now we complete the linear applications of op-amp. Now we start non-linear applications of op-amp, and first non-linear application is operational amplifier as an integrator. So write down the heading as op-amp as an integrator. Okay. Non-linear application of op-amp, that is op-amp as an integrator. So first we draw the circuit diagram of op-amp as a integrator. How many of you are there? डिस्कनेक्ट झालं तरी लगेच निघून नाही जायचं. वेट फॉर फ्यू मिनिट्स, 5 to 10 minutes. ऑटोमॅटिकली ते परत कनेक्ट होतं. डोंट लीव द क्लास. ओके. Okay, this one is a diagram of op-amp as an integrator. Now one important thing. Okay, now we try to derive the equation for operational amplifier as a integrator. Listen carefully, very simple. 2-3 steps you have to keep in mind. Above that, there are only mathematical calculations. So we start with this. In place of feedback resistance, if we connect capacitance in a feedback path, at that time that operational amplifier works as an integrator. And you know integration means what is the output? We expect output V0 is equal to integration of VI dt. And here we get minus 1 upon R into C. Integration of VI dt. Means output voltage is the integration of input and constant is minus 1 upon RC. Why we get minus sign? Because input voltage is provided to the inverting input. That's why we get output is the integration of input voltage. So this equation we have to derive, we have to prove mathematically that output voltage is equal to minus 1 upon RC integration of VI dt. Okay, so we start with, here you see the capacitance. Capacitance means C is equal to Q upon V. It holds the charge. Q is the charge on that capacitance. and V is the potential across that capacitance. Potential difference here, positive plate, negative plate. Potential difference is V. Q is the charge on that capacitance. Therefore, C is equal to Q upon V. So here, what is the potential? We have to write what is the potential across that capacitance. It is termed as VC. Before that, we have to write down the potential difference. IR is equal to VI minus 0. Here potential at that point S is 0 because that point is at virtual ground. We already see what is the difference between actual ground and virtual ground. Virtual ground means it sinks zero current and potential of that point is 0. But actual ground means it sinks maximum current and potential is 0. Means in both virtual ground and actual ground potential is 0. But in virtual ground current is also 0 and in actual ground current is maximum. Current flows towards the ground in actual ground. But here in virtual ground both current and potential are 0. Okay. Okay, so we start deriving this equation. So we write IR is the potential drop across this resistance, which is equal to potential at this point minus potential at this point. So VI minus 0, therefore we may write VI is equal to IR, or we write I is equal to VI upon R. Suppose this is equation number 1. After that, do you see this? Okay. After that, any problem? Brunmai, are you there? Kalpesh and Vedant? So we will continue. Okay. It's so simple. I write just for input current is given by input voltage upon that input resistance. Okay. Now what is the formula for C? You just know that C is equal to, if Q is the charge on that capacitor and V be the potential across that capacitance, then C is equal to Q upon V. Therefore, what you write, then V is termed as, what is V? Voltage across that capacitance. Just V is termed as a VC, because we may confuse between that V, this V and V0. V0 is the output voltage, Vi is the input voltage, and Vc is the voltage across the capacitance. So C is equal to Q upon V. This one is a general formula for capacitance, but just write C suffix. C is equal to Q upon Vc. So we rearrange this equation for Vc is equal to Q upon C. Okay, so Q is the integration of I, the charge Q. We may write that integration of I with respect to dt. Okay, overall I with respect to dt. So here in place of Q, we may write integration of I with respect to dt upon C. Okay, and now if we write actual Vc from figure, we write Vc is equal to actual. Practically, voltage across this capacitance given by potential at this point minus potential at this point. Write all these steps. These are all not mentioned in your textbook. So you do not understand that equation properly. So remember this, how you write Vc. Vc means the potential across this capacitance. Potential drop across that capacitance is given by potential at this point minus potential at this point. So at this point potential is 0. Therefore Vc is equal to 0 minus V0. Here potential at this point is output voltage. So we come to know that V0 is equal to minus Vc. Therefore, suppose this is our equation number 2, this is our equation number 3. Therefore, from equation 2 and 3, we come to know that V0 is equal to minus, where is R? Yes, fine. Okay. 1 and 3 minus integration of I dt upon C. Now we insert the value of I. What is the value of I? Vi upon R. Now I am going to insert the value of current I, which we already get here. I is equal to Vi upon R. So if we insert here Vi upon R, what is the equation? Vi upon Rc with respect to dt. As this resistance and capacitance having constant value, we may take out it common. Outside that, not common, so outside that integration sign, okay, Vi, therefore Vi is equal to minus 1 upon Rc integration of Vi dt. This is the, V0. In this way, we get the equation for output voltage, which is equal to V0 equal to minus 1 upon Rc integration of Vi dt. Here, output voltage is the integration of input voltage with some constant value minus 1 upon Rc. Again, I repeat this derivation. Here we draw first the circuit diagram of op-amp as an integrator. What is the difference between normal inverting op-amp and this integrating circuit? Here in inverting op-amp, here one resistance Ri and here another resistance Rf. Only that Rf is replaced by capacitance. At that time, that inverting op-amp is converted into integrator. Okay, that feedback resistance is replaced by capacitor. Then that inverting op-amp circuit is replaced by integrating circuit, operational amplifier as an integrator. So we start with this potential drop across this input resistance is given by IR. IR is equal to potential at this point minus potential at this point. So Vi minus 0 because this one is a virtual ground. So what we get, Vi is equal to IR. Therefore, we derive the equation for I. I is equal to Vi upon R. Okay, so this is equation number 1. Now after that we start with the equation of capacitance. Capacitance is given by Q upon Vc. Okay, capacitance is given by Q upon Vc. Therefore, Vc is the voltage drop across that capacitance, which may rearranging this equation we get Q upon C. Therefore, Vc is equal to, we know Q is always as, you may write here as Q is equal to integration of R dt. You know the equation of current, dq by dt. I is equal to dq by dt. Okay, exactly opposite we may write Q is equal to integration of I dt. So we replace Q by integration of I dt. After that, from figure, we try to write the potential drop across that capacitance, which is equal to Vc. Vc is given by potential at this point minus potential at this point. So 0 minus V0. We get Vc is equal to 0 minus V0. Therefore, V0 is equal to minus Vc, and we already calculate Vc. Therefore, V0 is equal to minus integration of I dt upon C. Only minus sign is there. And V0 is equal to minus integration. If we insert the value of I from equation 1, then we get minus integration of Vi upon Rc into dt, where you have to write from equation 1. Okay, from equation 1. Therefore, V0 is equal to minus 1 upon Rc integration of Vi dt. Okay, this one is the output equation for op-amp as an integrator. Do you understand? Do you have any question? Please ask if you have any question and write down all these steps properly in your notebook. Okay? Okay? Now here, if that VI input voltage, AC voltage is given by VI sin omega t. If that VI is given by V sin omega t. V is the amplitude of that wave. Omega is 2 pi f. Okay, angular velocity is given by 2 pi f and t is the time at that instant. In this way, suppose input voltage is represented by this, then what is the output voltage of that integrator? Minus 1 upon RC integration of V sin omega t with respect to dt. Right? Therefore, V0 is equal to minus 1 upon RC. Okay? Minus 1 upon RC, and that is the amplitude. You may take out this amplitude, and integration of sin omega t is minus cos omega t upon omega. This is the integration of sin omega t, that is minus cos omega t upon omega plus c. Right? You know integration better than me. I know these values only. You know all values you remember. What is the integration of sin omega t, cos omega t and all that things. Yes or no? Okay. So here what is the output? V0. V0 is given minus plus. Therefore, what you get? 1 upon omega RC V cos omega t plus C. Now from this you come to know that omega is at denominator and omega is given by 2 pi f. Therefore V0 is inversely proportional to omega. That is V0 is inversely proportional to 2 pi f. Means whenever frequency increases, output decreases. And whenever frequency decreases, output increases. Means this integrator works as a low pass filter because it get high output for the low frequencies. It provides high output for the low frequencies. Okay. So it is also termed as a low pass filter. Op-amp as an integrator is also termed as a low pass filter. So maximum time the question is like that. Why operational amplifier as an integrator is termed as a low pass filter? At that time you have to derive up to this. Or if the question is like that, explain op-amp as an integrator, then up to this point it is sufficient. Okay? Explain op-amp as an integrator जर आलं तर इथपर्यंत डिराइव करणं सफिशियंट असेल. पण op-amp, why it is termed as a low pass filter? At that time you have to increase these 4 steps also, and here you have to show that omega, that is equal to 2 pi f, is inversely proportional to output voltage. Means whenever frequency increases, output decreases, and whenever frequency decreases, output increases. Okay, that's why that op-amp as an integrator is termed as a low pass filter. So write down these steps also. All of you write down this one and write this one also. Fast. लिहून घ्या या दोन्ही तिन्ही steps. Okay, Kalpesh. Then, if you are having textbook, then there are some advantages of amp integrator and some disadvantages of op-amp integrator. Okay, op-amp integrator चे काही advantages दिलेले आहे, काही disadvantages दिले. What are the advantages? Advantages: it works as a low pass filter. Some waveform is also given. Whenever constant DC voltage is applied at the input of that op-amp integrator, ऐकताय carefully, op-amp integrator च्या input ला जर constant DC, you understand, constant DC voltage, no fluctuation, वाढणार नाही, कमी नाही होणार, constant. Suppose 5 millivolt is applied, for example, constant DC is applied. What is the output of that integrator? इंटिग्रेटरच्या इनपुटला जर कॉन्स्टंट डीसी व्होल्टेज अप्लाय केलं तर आउटपुटला काय मिळेल? वॅरिंग रॅम्प मीन्स इन्क्रीजिंग आउटपुट व्होल्टेज काय होईल? विथ रिस्पेक्ट टू टाइम वाढत जाईल. वाय ऍक्सिस वर जर आपण V0, आय एम गोइंग टू प्लॉट दॅट वन. इंटिग्रेटरला VI, सपोज कॉन्स्टंट डीसी व्होल्टेज VI is equal to then how you get output? Here you plot V0, here with respect to time, here output goes on increasing linearly. In this way you get the waveform. And AC, if you apply rectangular wave at the input, means rectangular means AC voltage. Suppose at the input you get the wave like this, rectangular wave. Then at the output, what do you get? Okay. In this way you get decreasing ramp. See the diagram? Oh. Okay, after that this one. Okay, in this way again we get up to this and this one, like that. Means for this increasing portion you get voltage like this. Okay, at the if rectangular wave is applied at the input of that integrator, then you get the signal like that at the output of that integrator. And in some advantages and disadvantages of that op-amp as an integrator are also discussed in the textbook. Go through it once. What are the advantages? Simple one, just op-amp integrator work as a low pass filter. This is one of the advantage. Okay, रॅम्प सिग्नल DC जर अप्लाय केलं तर आउटपुटला आपल्याला इन्क्रीजिंग पिक मिळते. दॅट इज ऑल्सो वन ऑफ द ॲडव्हान्टेज. ओके, Another advantage, we get the integration, means at the output. And what are the disadvantages? If there is a input offset voltage, then that is also integrated at the output. That is the disadvantage. If there is a bias current at the input of that integrator, then that current flows through the capacitance. If there is a small amount of input bias current, then that current flows through the capacitance, and due to that we cannot get proper output, exact integrated output. Okay, so after that, third disadvantage is that integrating time is large. Integrating time is large. Due to that, the charging time of capacitance increases. Due to that, there may leakage current. Capacitance ला खूप जास्त वेळ ते voltage होल्ड करून ठेवणं पॉसिबल नाही झालं तर there is a leakage current from one plate to another. Means capacitance cannot do properly, it cannot show the proper charge, it cannot hold that proper charge whenever there is a leakage of charges from one plate to another, and in this way we cannot get the proper value at the output. And it is a low pass filter, high frequencies, it cannot work properly at high frequencies. All these are the disadvantages. Means sometimes the special question on that integrator then state the advantages and disadvantages of op-amp as a integrator. So there are 3 advantages and 3 disadvantages of op-amp integrator. Go through it and remember this simple. ऑफसेट डिसएडव्हान्टेजेस मध्ये काय, ऑफसेट व्होल्टेज असेल तर ते पण इंटिग्रेट होतं, ते पण ॲम्प्लिफाईड होतं ॲट द आउटपुटला. बायस करंट त्या कॅपॅसिटन्स पर्यंत जातो म्हणून आपल्याला प्रॉपर इंटिग्रेटेड व्हॅल्यू मिळत नाही. दॅट इज द सेकंड. थर्ड वन, तो हाय फ्रिक्वेन्सीला प्रॉपर बिहेव करत नाही. दीज आर द डिसएडव्हान्टेजेस. अँड दिस क्वेश्चन इज ऑल्सो फॉर 3 marks. There is one exercise numerical. Try to simplify it. I think 8th numerical is op-amp as an integrator. Now we try to simplify that op-amp as an integrator. It requires just 5 minutes and 5 minutes remaining. We try to simplify that exercise numerical, and then tomorrow, not tomorrow, on Friday,